Hey guys, we're going to see an example on how you can show a function is surjective. So before we do that, let's really quickly just review the definition. So the definition says a function f mapping the set A to the set B is surjective if for all little b in B, there exists little a in A such that f of A equals B. So what this means is, intuitively, you can hit everything in B with something in A. And I just want to point out, so when we define a function, we have to define three pieces of information. We have to define the rule. So what exactly is this function? Like, is it x squared? Is it x cubed? And we also have to define what the domain and the range are. So if you have the same rule, like x squared, but you change up the domain, then you have different functions, even though their rule is the same. And if you play around with the domain and the range, you can actually affect whether or not your function will be surjective or not, without even changing the rule. Now, some more intuition. This is what you want to think of when you think of surjective functions. So this is the domain, and this is the range. And the arrows are specifically how you're mapping each element. So in a surjective function, every element in the domain is hit. You see there's an arrow pointing towards it. And it's okay if multiple elements point to the same element in the range, like in this case over here. As long as everything is hit by at least one arrow, you have a surjective function. On the other hand, here is an example of a function that's not surjective. Okay, and the reason why this function is not surjective is, okay, even though this element is being hit, this element is hit, this element is hit, however, this element has nothing mapping to it, so it would not be considered surjective. All right, so on to the problem. Now, it's a very simple example. So this is just to ensure that you can see how the proof for this kind of question works. And that way you're not too confused by the actual details. Rather, you can focus on the proof itself. So you want to show that the function f of x equals 2x is surjective. And more specifically, it's the function that maps R to R. So again, let's review the definition. We need to show that for all y in R, there exists an x in the domain R, such that f of x equals y. So every real number needs to have some number that maps to it, and it has to be a real number. So if there is some x value that gives us a y as an output, then it would have to satisfy 2x equals y, just because f of x equals 2x, that's the rule. And we just solve, so we get x equals y over 2. So now what we can say is the value y over 2 maps to y. So for any y in your range R, the value y over 2 maps to it. And also, this value y over 2 will always be in your function's domain. Because if y is an element of R, the reals, then y over 2 will also be a real number. So we've shown that this function is surjective. We've shown that if you have any real number y, there's always a number that maps to it, namely y over 2. And this number which maps to it, it's also going to be in our domain. That's a small thing that we need to check, because sometimes the number that maps to it might follow the rule, but it might not actually be in the domain. But in this case, that's all good. So the function is surjective. Okay, so this was an easy example, but I will do more difficult examples in the later video, because for now, I just want you to focus on how the proof works for these kinds of questions. And so that's all. Thanks for watching, guys.